How does the year 2023 compare with the past 2,000 years? Hello, friends. Jim here. Well, 2023 was the hottest summer in 2,000 years. Study finds. Here we see Professor Ulf Buntgen from the University of Cambridge, who's the co-author of this study that used tree ring data to make the ascertain this information. Researchers have found that 2023 was the hottest summer in the Northern Hemisphere in the past 2,000 years. Almost 4 degrees C warmer than the coldest summer during the same period. Although 2023 has been reported as the hottest year on record, the instrumental evidence only goes back as far as 1850 at best. Most records are also limited to certain regions. So now, by using past climate information from annually resolved tree rings over 2 millennia, scientists from the University of Cambridge and the Johannes Gutenberg University Mainz have shown how exceptional the summer 2023 was. Even allowing for natural climate variations over hundreds of years, 2023 was still the hottest summer since the height of the Roman Empire, exceeding the extremes of natural climate variability by 0.5 degrees Celsius. Yowzer. When you look at the long sweep of history, you can see just how dramatic recent global warming is, said co-author Professor Ulf Buntgen. And he's from Cambridge Department of Geography. 2023 was an exceptionally hot year, and this trend will continue unless we reduce greenhouse gas emissions dramatically. Well, of course, reducing greenhouse gas emissions is a desired thing to be doing, but don't forget the lag effect and the pipeline warming that's already in place. And the pesky thing called ocean heat content. There's a wee bit of that just waiting to discharge to the atmosphere. The results reported in the journal Nature also demonstrate that in the Northern Hemisphere, the 2015 Paris Agreement to limit warming to 1.5 C above pre-industrial levels has already been breached. If I recall correctly, it was something like 87 days in 2023 where the worldwide average temperature was above 1.5. And I'm seeing recent measurements of the global average temperature reaching 1.6. I think it's safe to say that there's no way we're going to keep the Paris Agreement to under 1.5. Early instrumental temperature records from 1850 to 1900 are sparse and inconsistent. The researchers compared early instrumental data with a large-scale tree ring data set and found the 19th century temperature baseline used to contextualize global warming is several tenths of a degree Celsius colder than previously thought. By recalibrating this baseline, the researchers calculated that summer 2023 conditions in the Northern Hemisphere were 2.07 C warmer than mean summer temperatures between 1850 and 1900. Many of the conversations we have around global warming are tied to a baseline temperature from the mid-19th century, but why is this the baseline? What is normal in the context of a constantly changing climate when we've only got 150 years of meteorological measurements? Only when we look at climate reconstructions can we better account for natural variability and put recent anthropogenic climate change into context, said Ulf. Tree rings can provide that context, since they contain annually resolved and absolutely dated information about past summer temperatures. Using tree ring chronologies allows researchers to look much further back in time without the uncertainty associated with some early instrumental measurements. The available tree ring data reveals that most of the cooler periods over the past 2,000 years, such as the Little Antique Ice Age in the 6th century and the Little Ice Age in the early 19th century, followed large sulfur-rich volcanic eruptions. These eruptions spewed huge amounts of aerosols into the stratosphere, triggering rapid surface cooling. The coldest summer of the past 2,000 years, in 536 CE, followed one such eruption, was 3.93 C colder than the summer of 2023. Most of the warmer periods covered by the tree ring data can be attributed to the ENSO cycles. El Nino affects weather worldwide due to weakened trade winds in the Pacific Ocean and often results in warmer summers in the northern hemisphere. While El Nino events were first noted by fishermen in the 17th century, they can be observed in the tree ring data much further back in time. However, over the past 60 years, global warming caused by greenhouse gas emissions are causing El Nino events to become stronger, resulting in hotter summers. The current El Nino event is expected to continue into early summer 2024. Well, no. That El Nino event has already fizzled out. It was intense, but we're already back into a neutral state right now. So will this saying that this summer will break temperature records again? We'll see. We're approaching it. It's true that the climate is always changing, but the warming in 2023 caused by greenhouse gases additionally amplified by El Nino conditions, so we end up with longer and more severe heat waves and extended periods of drought, said Professor Jan Esper, the lead author of the study from the Johannes Gutenberg Institution. When you look at the big picture, it shows just how urgent it is that we reduce greenhouse gas emissions at once. The researchers note that while their results are robust for the Northern Hemisphere, it is difficult to obtain global averages for the same period since data is sparse for the Southern Hemisphere. And the Southern Hemisphere responds differently, since it's much more ocean covered than the Northern Hemisphere. Okay. Now they talk here, El Nino events are becoming stronger. True. But here's the flip side on that. We're going into the projections are we're going into a La Nina event later this year. The coldest La Ninas of recent years is warmer than the hottest El Ninos of 30, 40 years ago. Let me repeat that. The coldest La Ninas of recent years are still warmer than the hottest El Ninos of 30, 40 years ago. There is a boatload of ocean heat energy, and it's starting to do things. So still, the trend is unmistakable. We're warming the planet up. I think this is, I like this approach of using the tree rings. There's, let's see if we can pull up the results. Yep. Here's the paper, and you got to pay $30 to access it. So, because I wanted to see, if they utilize isotopic fractionation. So there you have it. We're really messing things up such that, within, 2,000 years, that's a geological blink. And look how drastically different things are, how much warmer they are. So, until next time, thank you for your time.